Hello everyone, I'll be talking about the classification of cyclopentadienyl dicarbonyl dimer using the four classification methods. The structure of this organometallic complex is a structure that each iron center is bound to an 8 to 5 cyclopentadienyl ligand, two carbonyl ligands, and the two metals are directly bonded to each other. Each iron atom is formally in the +1 oxidation state, given a 17 electron monomer, but dimerization with an iron-iron bond brings each iron center to an 18 electron configuration. Each metal center is iron, which is a first row transition metal in a D block, which places it under the transition metal category. Transition metals like iron possess partially filled d orbitals, which allows them to participate in diverse bonding modes like sigma donation and pi back bonding. The 8 to 5 cyclopentadienyl ligand acts as a pi bonding electron pair donor, contributing to localized electron density from its aromatic ring into the metal's d orbitals. The 5 carbon atoms contribute a continuous pi electron cloud that overlaps with the iron's d orbitals, forming strong multi-centered pi interactions rather than simple sigma donation. And then the next ligand is the terminal carbonyl ligand, which acts as a sigma donor pi acceptor. In the sigma donor mode, the carbonyl carbon donates a lone pair in an sp hybrid orbital directly into an empty orbital on the iron center, forming a strong sigma bond. And the carbonyl is also a powerful pi acceptor because its pi star and antibonding orbitals overlap with filled metal d orbitals, allowing pi back bonding from iron to carbonyl to stabilize the complex and weaken the carbon-oxygen bond. And then the bridging carbonyl ligand also acts as a sigma donor pi acceptor to donate sigma electron density, but distributes this donation to both iron centers, and its pi acceptor ability is present but reduced compared to the terminal carbonyl. The third classification is hapticity, which is the number of contiguous atoms in the ligand that are directly bonded to the metal center. And then the 8 to 5 cyclopentadienyl ligand binds to each iron through 5 contiguous carbon atoms, giving it a hapticity of 5, because the cyclopentadienyl ring serves as an aromatic delocalized pi system, where all 5 carbons participate in coordinated pi bonding with the metal. And then the terminal carbonyl binds to a single carbon atom, giving them a hapticity of 1. Carbonyl is a linear ligand with a lone pair on carbon that forms a sigma bond to the metal, since only the carbon bonds directly to the metal center. And then the bridging carbonyl ligand also has a hapticity of 1, even though it connects two iron atoms together. The bridging doesn't increase hapticity, it only changes the connectivity. And in a mu carbonyl ligand, the carbon atom donates electron density to both iron centers, but only one carbon atom forms the metal ligand interaction, and the oxygen atom doesn't bind to either of the iron atoms, so the carbonyl remains at hapticity 1. In classification D, the ligands are classified based on their polarizability. The cyclopentadienyl ligand is a soft pi donor ligand because its aromatic pi system is highly delocalized, which makes it readily polarizable. The delocalization allows the ligand to adjust its electron density to iron's electronic requirements. Both the terminal and bridging carbonyl ligands are also soft ligands, specifically soft pi acceptor ligands, because its low-lying pi star orbitals are highly polarizable and can accept electron density from iron via pi back bonding. And then the iron centers are also classified as soft metals, especially in low-valent organometallic environments where the d electrons are abundant and more easily polarizable. Soft metals also prefer to bind to soft ligands to create a stable interaction throughout the complex. And these are my references. Thank you.